Hey everybody, this is Larry. This is day 28 of the January Leetcode Daily Challenge. Uh, Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem. And just, yeah, wait. Is it 28? Yeah, okay. I guess it's just have to hit the refresh button. But yeah, hope everyone's having a good day, a good weekend, or a good week. Life is tough, life is weird, life is tricky. So I hope everyone appreciate what y'all have. And it's not clickable. I have to refresh it again. This technology stuff is way weird. Is my computer being like nothing is clickable? Sorry, technical difficulty, as I'm saying. These are recorded live, so yeah. And so also so you could see my thought process for this silly things like this. But yeah, life is short. Appreciate people around you. That's all I say for today. Smallest string with a given numeric value. Okay, let's see. What does that mean? Lowercase, so A is 1, B is 2. Okay, so fourth string is ABC is 1 plus 2. Okay. Lexicographically smallest string with length equal to n, and okay. I think this is just greedy. Let's see. I think I go over this a lot, or not, like in different problems. I think, and I guess mine stuff is Java, but yeah. Yeah. So basically, and this is just from experience, these are going to be for lexicographically smallest. For this one, it probably is going to be greedy because it's just sum. Yeah, because it's the sum and stuff like that. And you can have small cases to prove to yourself. The short story is was it smallest or largest? Okay. Yeah, so you have like two numbers, 2 1 and 2 1, or sorry, 1 2 and 2 1. They both obviously sum to 3. And you always want the smallest number in the beginning. So that's basically the idea behind greedy. And then the question is, well, how can you do this in a good way? N is 10 to the fifth, so we just have to do it in linear times 26 is what my guess is. What I mean by that is just doing it one digit at a time and then use math to determine whether we can solve the rest, right? So we'll do the math together. I don't know the math off my head because I'm not that good at math, but yeah. Yeah, but for example, in this case, we have n equals to 3, k is equal to 27. Well, we see if a, the first character could be a, and if the first character could be a, what does that mean, right? That means that n is equal to 2, k is equal to 26 is possible. And then we try again for is the second character, I think a again is good. Yeah, a, which means n is equal to 1 left and k is 25 is possible, right? And whether this is possible is just all math, right? Because in the worst case, in the worst case, the last nth letter is just all gonna be z's or z's. So then that's just equal to 26 times n is the maximum number, right? Where n is the number of n remaining. So that's basically the greedy idea that I have and gonna try. And because you can do this one digit at a time, it's gonna be 26 times n in the maximal case, so which is going to be fast enough in this case. And you could call it O of alpha times n or 26 times n, which is O of n or something like that. So yeah, let's get started. Okay. So yeah, so I have a result. I'm gonna make. I think we could go either way. Sometimes I like doing this and then just add concat to it. Let's do it that way. I think. I actually don't know if Python optimizes it, so we can also, if it's too slow, we can make it in a way and then do one join at the very end. But I'll write it the way that I want it to be written. And then now we just do one at a time, which is, which one is the digit again? N? Okay. So how do we want to write it? So for index in range sub n, so what is this, right? So then we try one at a time. So for C for character is in range of 26, say. Wait, is it? It's 1 to 27, I guess, right? Because A is 1. So let's do that. I mean, you could change the for loop in any way you like, but Is it 1 to 26 or 1 to 27? No, it's still to 25, so it's 1 to 26. So this is good. And then, let's go it. Yeah. And then basically now, how many digits do you have left, right? Well, the number of digits left is just equal to n minus index minus 1, because you want to consider this character. And actually, I'll just move. This is obvious that doesn't change, so I'm going to move this outside. And then k will progress. So the digits left not in, and this is digits left not including this current digit. So yeah. So if digits left times 26 as we said, if this is less than k, if this is, let's see, yeah, if this is greater than or equal to k, then this is good, right? It's k minus c. Yeah, right, because c is the digit that we're taking off. If this is just the current k that will remove, and this is the rest of the string that we will be all z's. But so another way of thinking about it maybe is just that you have a string of all z's, and this will give you some k or some value, and then one at a time you choose a. Will this sum be at least k or more? If this is true, then then this is good. Otherwise, if it's not, you try b. Is this good enough, right? Is this at least k or more? And that's basically the idea here. And this is it in math form. So if this is true, k we minus c for using this character. We increment, and this in Python this is a little bit messy, but we just change it from we just use this to convert it to the character, and I think that should be it. Yeah, let's give it a go. I feel like this is mostly it, but I feel like maybe I'm missing oh no, I need this to break, because you only need to do it once, because if this is not true, then you need c to be smaller. Is there a -1 value thing where this is too small? It doesn't seem like it. Like, what is the... Okay, let's try the other examples. I guess I'm just trying to think about, like, what if I have like 5 and 4, so it's not possible or something. But maybe that's in the constraint. Oh yeah, okay. So it has to be at least that. So yeah, so maybe I was trying to look for that constraint. So let's get... Oops. What? Yeah, that looks okay for now. So let's try some 0. I actually don't know. 0. Okay, 0 case is okay. So 1 and I don't know, 7 or something. So it looks okay. So let's give it a submit. Oh no, is it too slow? Oh no. Okay, that's fast enough though. Yeah, so that's basically the idea. You do it one digit at a time, and I think the better visualization is actually what I said earlier, where you, instead of trying to do it whatever, you just have a string of z's, where this is length n, and then you try with a. You try to see if this is bigger than k. If it's not, then you try b. Is this k or bigger? If this is bigger than k, then we could go to the next digit. You try a again, you try b again, you try c again, and so forth. I think also there is an optimization that I've just realized that I didn't when I was doing it, which is that I think it doesn't make sense to try a, b, and then a, because if there's an answer such that there's a b and then a, you actually convert it from an a to a b. So actually you could optimize this a little bit by setting up this as the last digit. So that should make things run a lot faster, but obviously, as you saw, it's not really even necessary. And in terms of big O, it doesn't change anything, so that's okay. So what is this? Well, this is given that alpha is 27 or 26, I guess. This is of alpha times n, so or O of 26 times n, or O of n, which is linear in the size of the no, that's not true. Well, n is the yeah, so it's just O of n. And in terms of the result, of course, that's also O of n because that is the length of the output. Of course, that is not linear in the size of the input because the size of the input is constant. It's just an int, but it is O of n. Cool. Yeah, this technique of greedy and doing one digit at a time comes up a lot, so I definitely recommend just playing around with it. I don't know if it comes up that much, but the idea is coming up with coming up with an invariant that you can see change as things go. That comes up a bit, and in this case is and like I said, actually I came up with this visualization just now, so I think maybe that's a better visualization of just doing a one, instead of quote unquote force one digit at a time, we just check everything as the biggest and then we swap them to be, yeah, maybe that's a better visualization. Let me know what you think. Yeah, so that's all I have. Everyone, please take care of yourself, take care of others around you if you're lucky. Stay good, do well, and to good mental health. And I will see you tomorrow. Bye bye.